So over the last few years at the Sea Mammal Research Unit, we've been doing a lot of work to develop technologies to track marine mammals around activities, human activities that are perceived as high risk for marine mammals, such as pile driving, tidal turbines. For many species, the tools and technologies available to do that have been around for many years. Passive acoustic monitoring for those species that make distinctive vocalizations underwater. But for species such as seals, which don't make a lot of sound underwater, the tools were very, very limited. So we spent a lot of time looking through the potential tools that we could use to do this. Underwater video, for example, we looked into, but unfortunately for many areas the visibility isn't good enough. Passive acoustic monitoring, as I said, isn't good enough because seals don't produce vocalizations. But one technology we did think had a great deal of promise was active sonar, multi-beam imaging sonar. So this is a tool that produces sound in the marine environment, and it detects the echoes from various objects in the water column. And this is being used more and more for a range of applications such as harbour security or ROV navigation or fisheries research. So the very first step, we went out and reviewed all the systems that were available off the shelf, and one of the key things that we felt we needed to test at the first step was the acoustic emissions that were produced with these active sonars, and ensuring that the outputs didn't have an effect on the animal behaviour itself. So we spent a lot of time testing a lot of different systems in our captive facility at the Sea Mammal Research Unit, and brought it down to a small list of 2 or 3 systems which we felt could do the job on paper and also didn't elicit behavioural responses by the animals. We then took these active sonars out into the wild and collected a whole bunch of data on marine mammals, on various other animals that are out there, fish, seabirds, and also other targets which are potentially mobile in the marine environment, things like seaweed, bits of debris such as logs and things. And one of the most important things we wanted to do with these data is to see whether we could effectively differentiate marine mammals, seals, from these other targets which are in the marine environment. So we use a series of cutting-edge machine learning techniques to try and classify our seals from all these other targets. And the results were very encouraging, actually. From the classification algorithms that we developed, we had a false negative rate of 0, so it successfully classified all our seals as seals. We had a relatively low false positive rate, so it classified about 8% of the non-seal targets as seals. So we were really encouraged by the classification success of these algorithms we developed. And we're now looking to take these algorithms and these systems out into applications such as tidal turbine deployments to actually start to collect data on animal movements and animal presence around these activities.